Hey class, today we're going to continue on with chapter 3, but we're going to move off of solid, liquid, and gases, and we're going to go to part 2, and we're going to specifically focus on the gas laws. This chapter starts off by talking about breathing. When you inhale, in other words, breathe in, the volume or the amount of space within your chest cavity increases, and this actually forces air to move into your lungs. And then when you exhale or breathe out, the volume or space within your chest cavity is going to decrease, and this causes air to be pushed out of your lungs. Now, this change in volume and then changes in temperature and pressure and how many particles of gas are in your lungs versus out of your lungs actually help us predict how gases behave. So we're going to look at first pressure. We have to understand, what does this term actually mean? And our key question here says, what causes gas pressure in a closed container? We first have to understand that pressure is the result of two things: force distributed over an area. So typically our equation for pressure is pressure equals force divided by area. This is going to occur whenever you push against something. Your push is the force, and then however big the object is you're using to push is going to be the area. So what exactly causes pressure? Well, anytime gas particles collide with the walls of the container, they're causing pressure within that closed container. Also, it also includes collisions that happen between the gas particles within that container as well. A good example that we can use to help us illustrate pressure is a moving hockey puck is going to exert pressure on any object that it's hitting because it's hitting with a force, and of course, the amount of area that it hits would be the area. This is why we keep a layer of shatterproof glass around the spectators, because hockey pucks can get moving pretty quick. One thing to know is that the faster something's moving, typically the greater the force that it's going to hit with. And greater force means more pressure. So one thing to take away from this sentence is right here. If your force increases, the amount of pressure being exerted is also going to increase. And we have to understand that this is a direct proportion or a direct relationship because both of them are going in the same direction. Now that we kind of see how force and pressure are related, we also have to take into account area as part of your pressure equation. So let's look at area. It says the smaller the area of impact is, so if the area gets smaller, it says the greater the pressure. Pressure is actually going to increase. If you hit something with the edge of the puck, it's going to have more pressure than if it were to hit on a flat surface. Also, just think about sharp utensils. If you have a sharp knife, you don't have to apply as much force to cut through something versus a dull knife. Or if we think about in terms of poking somebody with a marker, which has a high area, doesn't hurt as much as poking something with a little tiny point. So when we look at pressure, there's something I want to say on this. This is going to be down and up, so we want to know that this is an inverse proportion that we learned from chapter 1. Now, the SI unit of pressure is going to be derived from our SI unit of force and area. So let's kind of go over units that you guys need to know. Force, its unit is going to be newtons, which is written with a capital N. Area is a derived unit from taking length times width. So our SI unit is meters squared. And this causes our SI unit for pressure is going to be abbreviated Pascal, or capital P, lowercase a. Pascal is actually going to be shorthand for newtons per meter squared. So Pascal actually equals newtons divided by meter squared because we're taking force divided by an area. Now, scientists can use other units for pressure, or they can add prefixes in front of it. So Pascal can add the prefix kilo to make it a little bit bigger. Now we are going to look at in terms of gases. We know that they constantly move. Helium is a gas that we learned about that's constantly moving within a balloon. There are more than 10 to the 22nd helium atoms in just a tiny balloon, which is thousands upon thousands of helium atoms. All of these particles or gas molecules are going to collide with each other and collide with the walls of that balloon, and they're going to create a pressure. The more frequent that they collide, the greater the pressure is. So on this sentence, we need to understand that if our collisions increase, my pressure also increases. So again, this is a direct proportion. We're also going to talk about speed and mass because those also do affect pressure as well. Besides those things, we're going to talk about specifically other things that affect pressure too. Factors that also affect pressure of an enclosed gas are going to be temperature, volume, and the last thing is how many particles there are, or the number of particles. Focusing on temperature, it says raising the temperature of a gas will increase its pressure if the volume of the gas and number of particles are constant. And when I say constant, it means kept the same. So again, raising the temp, so that means if temp increases, my pressure will also increase. Again, this is a direct proportion because the arrows are going in the same way. And that means if temperature decreased, pressure would also decrease as well. A good example of this is if you are beginning to become a driver, or if you're in driver's ed, we want to make sure that the pressure within your tires is at a good level. And one thing that you're going to notice about tires is that they lose and gain air depending on the temperature outside. This one, he says, if the firefighter checks the tire pressure after a long drive, he's going to find that the pressure increased. So let's figure out why. The reason pressure would increase after a long drive is because as your tires are driving over the highway, they heat up. So we're going to see that temperature increase. When things heat up, they tend to move at a quicker pace. So we have the average kinetic energy also increases. This means the particles are moving faster, they're colliding more often. And when they collide more often, they're going to have more pressure. So more collisions and a greater force has more pressure within the tires. You might also see in the winter that tire pressure tends to go down because it gets colder outside. So if it gets colder outside, you tend to see a decrease in tire pressure. The second factor is going to be volume. Here it says reducing the volume. So reducing means volume is going down. It says there's going to be an increase in pressure. That means pressure is going to increase as long as temperature and the number of particles are constant, or as long as those two things are held the same. This is something that we're going to see as an inverse proportion. So as one goes down, the other goes up. And this should make sense. If we take the volume of something and we shrink it down, those particles are a lot closer together, and they're going to be more likely to hit each other. It's kind of like if I take you and I put you in the gym, you have a lot of volume, less likely to be collisions. But if I took all of you guys and put you in a tiny room like the office and had you guys run around, you're more likely to collide with one another because you're in a smaller space. So a good example of this is if you take a plastic water bottle and you twist the cap on it and then squeeze it, you're going to see that you have decreased the volume, and that's going to increase the pressure. The other time that we see volume and pressure is when we inhale and exhale, like we talked about at the beginning of the lesson. We have this muscle called a diaphragm in our body. It's just situated right below our lungs. And this diaphragm will contract and relax to change the volume within your chest. So, right here is the diaphragm, and our diaphragm is actually contracting here. So, it says that when we inhale, our volume increases when you inhale. And this causes pressure to go down. And one thing to know is that pressure flows from high pressure to low pressure. So if we increase volume, that means we have low pressure within the lungs, high pressure outside the lungs, and so air flows in. When we exhale, our diaphragm right here, notice that it relaxes and goes back into this U shape. And notice our volume actually decreased. And that means our pressure is going to increase within our lungs. So that means we have high pressure inside our lungs, low pressure outside our lungs, which causes our lungs to push out air and allow us to exhale. The last thing we're going to focus on is the number of particles. One thing to know about the number of particles is if you increase the number of particles, so that means if particles increases, we're going to see that the pressure also increases. Again, notice both arrows are the same way, so this is a direct proportion. If you add more particles and keep the volume the same, you're adding more things to be able to collide with one another. So our number of collisions go up, and therefore we have more pressure. So we have to understand this relationship. It would be like if I took 2 other classes and brought them in the classroom with you, you're more likely to hit something or run into something because there's more bodies in the room. And that's the end of today's lesson. One thing I would really make sure that you understand is the relationship between all of these different things that we talked about: pressure, collisions, area, force, temperature, and volume, and whether they're inverse versus direct. Let me know if you have any questions, and I hope you guys have a great day.